Hi everyone, my name is Julia. I'm a program manager on the Visual C++ team at Microsoft, focusing specifically on Visual Studio Code. Thanks for tuning into my session today. I hope you're excited to learn about cross-platform C++ development in VS Code. I'm going to start by diving into the rich, productive editing features of the C++ extension. I'll show you how to build and debug SuperTux, an open source game, on Mac using the C++ extension, the CMake Tools extension, and VC package. Then I'll use the remote SSH extension to build and debug a CMake project on my Linux VM. This demo will showcase a brand new VC package feature that actually hasn't been released yet. Finally, I'll show you how to optimize Visual Studio Code for collaborative development. I'm sure many of you have either contributed to an open source project or shared code between classmates and coworkers. So I'm going to show you how to integrate GitHub with VS Code so that you can interact with pull requests and issues directly from the editor. Let's get started. Okay, so there are a few things you need to do before diving right into C++ development on VS Code. The first is install Visual Studio Code, which you can do by following the link on the slide. And the second thing is install a C++ compiler. The C++ extension uses the compiler that you have installed on your machine to configure IntelliSense. Some popular choices for C++ compilers are GCC for Linux, GCC for Windows, Microsoft C++ on Windows, and Clang on Mac OS. In today's demo, I'll be building SuperTux and editing SuperTux on my Mac laptop. And I have Clang installed on my Mac laptop. You can learn more about installing these compilers on your machines and setting up VS Code and the C++ extension by following that link, the second link on the slide. In today's demo, I will be building SuperTux. SuperTux is an open source cross-platform game. You can clone the GitHub repository, the link is in the slide, and build this on your computer as well. A lot of people contribute to this game. It's got a great developer community, so it's a great project for demos. I'm going to open SuperTux in VS Code directly from the terminal. So I've navigated to my SuperTux project directory. Now I'm just going to type code dot, and this opens my SuperTux project folder in Visual Studio Code. So the first set of features that I'm going to show you in VS Code are the core editing productivity features provided by the C++ extension, such as IntelliSense, go to definition, find all references, rename, etc. You can install this extension through the marketplace by clicking on this extensions marketplace icon on the left. And here you can see the ones that I already have enabled on my computer. All right, let's go back to our source code. So the first feature of IntelliSense that I want to show you is type information. So let's say you're curious about what this timer type is right here for this mstate timer variable. You can just hover over timer and a little window will pop up with some information about what this class is. So we see simple timer designed to be used in the update functions of objects. If you're curious about the vector class, for example, you hover over vector and you get some information about what a vector is. So let's say I want to find all references of this mstate timer variable. I can do Control-click and select Find All References. And this will find semantic matches and non-semantic matches if they exist. So these are just confirmed references. So let's say I go to my CPP file and I want to see what kind of functions I can use on this mstate timer variable. So if I start typing mstate timer and then dot, the C++ extension will provide a list of method member functions for the timer class. So you can press tab to select the method and then parentheses, and then you'll see information about the arguments that this function takes. Okay, so now I'm in my badguy.cpp file. Let's say I wanted to check out the definition of this variable again. I can do Control-click go to definition, or you can just use the keyboard shortcut F12, and that takes you to your header file. Let's say you wanted to see what the definition was, but you didn't actually want to navigate to the header file. You could just do peek definition instead of go to definition, which is Control-Shift-Peek, peek definition. And this little window pops up with a preview of where the definition is and what it is, but you can dismiss it and you're still in your .cpp file. So now let's talk a little bit about the refactoring capabilities, such as rename symbol. I'm going to go back to my bad guy header file, and let's say this vector. I want to rename this vector mFloorNormal to xFloorNormal. So I will do Control-Shift rename symbol, or you can do the keyboard shortcut F2. And I'm going to type xFloorNormal. However, I want to preview all of the places that this variable will be changed before actually applying those changes. So I'm going to do Shift-Enter instead of just Enter. And this will search for, as I said before, confirmed and non-confirmed references of this variable. So a confirmed reference is not only a text match, it's a semantic match. And a non-confirmed reference means it's a text match, but it may not necessarily be a semantic match. It could be in a string, in a comment, or an inactive code block, etc. All right, so this refactor preview just appeared. And you can see here, these are the confirmed references, and those are automatically selected for us to be included in our rename. You can hover over this icon to see that it's a confirmed reference. If you want to actually look at this and see what the change will be, you can select it, and you can see side by side what the old and the new version will look like. So these are the non-confirmed references down here that aren't automatically selected. You can select those and choose to include them in your rename, and you can unselect the confirmed matches as well. Once you've clicked through and decided that these are the ones that you want to rename, you can apply your refactoring by selecting this check mark in the right-hand side of the refactor preview window. You can complement the C++ extension with the C++ themes extension. This extension provides a dark and light color theme that closely resembles the Visual Studio color theme and supports C++ semantic colorization. So you can quickly change the color theme from the extension welcome page. And this is what the light mode looks like. You can also change this color theme in your Visual Studio Code settings. You can do that by hitting Command-Shift-P and type Preferences, and then select Open Workspace Settings. So these are your Visual Studio Code settings, and you can set them for either your workspace or at the user level. So we'll search for theme, and here, this Workbench Color Theme property, you can see we have it selected as Visual Studio Lite C++. So these are the ones that are provided by that extension, and again, they actually support C++ specific semantic colorization. To learn more about customizing semantic colorization, check out our docs online. I'm more of a dark theme person, so I'm switching back to Visual Studio Dark C++. So now you've seen some of the core editing features of the C++ extension. Let's dive into how we can use VS Code for cross-platform C++ development. C++ development is super popular these days. Whether you are targeting a platform that's different from your host OS, either by remote development or cross-compiling, or you are actually developing on different machines and different host operating systems, Visual Studio Code supports all of those scenarios. It's a great option for cross-platform development because it runs on Linux, Windows, and Mac. It has first-class CMake support through the CMake Tools extension, and CMake is a cross-platform meta build system. Because of its cross-platform functionality, it's a very popular choice for building open source projects or shared projects. VS Code also integrates with itCppCon20, which is a cross-platform command line package manager for C++. We see in surveys that package management tends to be a pain point for C++ developers, so I'm going to show you how you can use itCppCon20 to manage your project dependencies and make that experience a little bit easier. VS Code has great remote development through the Remote Development Extension Pack. Today I'll be showing you specifically the Remote SSH extension. And you can also configure your IntelliSense in the C++ extension for cross-compiling scenarios. Let's say you are using VS Code in the extension on your Windows computer, but you are compiling for ARM. You can tell the extension that you're compiling for ARM, and the IntelliSense will work for that cross-compiling scenario. Let's take a look at how all this works together by building SuperTux on Mac using CMake Tools and vcpackage. You can install the CMake Tools extension through the Extension Marketplace. The CMake Tools extension makes it very simple to configure, build, and debug your CMake projects in Visual Studio Code. You can create a new CMake project or configure an existing CMake project. CMake projects all have a CMakeList.txt script that tells CMake how to build your project. If your project already has a CMake list script in the root directory, the extension will automatically pick that up. If it's not in the root directory, you can tell the extension where to find it. So this SuperTux project already has a CMake list script in the project root folder. So we're ready to start configuring our project. There are two things that you need to do to configure your project with the CMake Tools extension. The first is select a kit, and the second is select a variant. A kit contains the project agnostic, configuration agnostic, build instructions for your code, such as the name of the compiler that you're using. You can select a kit by invoking the command from the command palette. So do Command-Shift-P to open the command palette. Type CMake, select a kit. The CMake Tools extension scans for compilers on your computer, and you can see them listed in the drop-down. If you want to rescan, you can select Scan for Kits. After scanning, if the compiler that you want to use isn't showing up in this list, you can edit the CMake Tools Kits JSON file directly and add it yourself. So I'm going to select Clang. You'll notice that this kit that's loaded is reflected in the status bar down here. So all of these commands in the status bar are provided by the CMake Tools extension. You can invoke them through the command palette, just like I did earlier, through Command-Shift-P, or you can just click on them in the status bar, same thing. If your status bar is getting too crowded, maybe there are commands from other extensions down there, you can collapse these buttons so it just shows the icon instead of the label by editing your settings, or you can hide them all together if you'd rather just invoke them from the command palette. All right, so we selected our kit. Now we're ready to select a variant. A variant contains the build instructions for your project. By default, CMake Tools provides 4 variants, each mapping to a default build type. So let's select the variant through the status bar. And I'm going to select debug to include debug information with my build. All right, so we're automatically configuring the project, and it was successful. Our build files have been written to this build folder in my SuperTux project. All right, so our build files have been written. We're ready to build. We can just select this build icon in the status bar, and next to build, you'll notice it says all. So these are the active targets to build. By default, we are building all targets, but you can click on it and search for the target that you want to build if you don't want to build all. I'm going to build all. All right, let's hit build. Build finished with exit code 0. We're good to go. So now that we've successfully built our project, we can go ahead and debug. I'm going to open my main.cpp file and set a breakpoint right here, line 23. And to debug our project, we can use the quick debug button in the CMake Tools extension commands down here in the status bar. And we can also select this CMake icon on the left to view our CMake targets here. Then you can do Control-click and build, debug, open CMake lists, script, etc., all for this CMake target. So I'm going to select debug from here. And this is launching the debugger. So let's take a few moments to look at some of the UI changes with the debugger. So in the debug console, you'll see output that the debugger is up and running successfully. On the left, we have some useful debugging information, such as the value of our local arguments, watch variables, so you can create watch variables here if you want to watch how the value of an expression changes over time. We have our call stack, our breakpoints, so you can enable and disable breakpoints, add new breakpoints directly within the debugger. All right, so let's keep running our project. And this command bar at the top, you can drag it around. You can continue, which will continue running the code. We have step over to step to the next line, step into to go into a function, step out, restart, and stop. So let's continue running our program. And there we go, our SuperTux game has launched. So we just successfully built SuperTux on Mac using the CMake Tools extension in Visual Studio Code. And those were the general steps for configuring, building, debugging a CMake project using the CMake Tools extension. But what I didn't show you was how I integrated CMake Tools with VCPackage to manage all of SuperTux's dependencies, which there are a lot of. So I'm going to take a step back and show you how I used VCPackage for that. But first, let me give you a little bit of information about VCPackage and why it's a good choice for cross-platform C++ development. VCPackage is a cross-platform command line package manager for C++. It's open source and it has over 1,300 libraries in the VCPackage catalog across Windows, Linux, and Mac. There are a lot of benefits to using VCPackage for package management. Package management is known to be a pain point for many C++ developers, but VCPackage simplifies that acquisition and installation of third-party libraries because all you need to do is run VCPackage install and the name of the library from the command line. And all of the libraries in the VCPackage catalog are routinely tested against each other to ensure compatibility and a high-quality catalog. So the last thing I'll mention is that you can integrate VCPackage with CMake and Visual Studio Code so that when you're building your CMake projects in VS Code, they're able to find all of those packages that you installed with VCPackage. Installing VCPackage is very easy. There are 3 steps. All you need to do is clone the VCPackage GitHub repository, run the bootstrapper in that project root directory, and then run the command vcpackage integrate install from the command line. This will enable you to hook VCPackage up to CMake, so CMake can look for packages in that specific instance of VCPackage, and Visual Studio Code can use VCPackage to configure IntelliSense for source files. The steps are the same across Linux, Windows, and Mac. Okay, so I cloned the VCPackage GitHub repository, ran the bootstrapper, and I've already installed the libraries needed to build SuperTux, which is why the build was successful earlier on in the demo. But I'm still going to show you the VCPackage integrate install command. So let me navigate to my VCPackage folder. And I'm going to run vcpackage integrate install. So here it tells me what I need to set my CMake toolchain file path to be so that I can find the packages installed with this instance of VCPackage on my computer. So to use this with the CMake Tools extension in Visual Studio Code, you can set this property for CMake Tools in your settings.json file for your workspace. So the settings.json file lives in this .vscode folder in your project. If you don't see one, that just means you haven't edited any workspace level settings yet, and you can create one by doing Command-Shift-P and opening the command palette and typing Preferences, Open Workspace Settings. So here's the UI to edit VS Code settings. You can apply them to your workspace or at the user level. So let's go down to Extensions, select CMake Tools, and we're looking for Configure Settings. Here we go. So you can click this button here that says edit in settings.json. And I already have this JSON file created, so you can see there's a bunch of other stuff in it. But here for CMake configure settings, I have the CMake toolchain file path set, which was the value that was given to me by running vcpackage integrate install, that path right down there. And I have vcpackage build property set to on. And then when we configure the project, I'm going to configure it again so you can actually see the output, how it's finding these packages through vcpackage. There we go. So as you see here, it passed the toolchain file path, and then it found all of the required packages. A few of the non-required ones are not found because they're not installed, but the build files have been written, configuration was successful. So it's that easy. Install vcpackage, install your dependencies, set this property in your settings.json to the CMake toolchain file path, and your build will be successful. So I started off by saying that CMake and vcpackage and Visual Studio Code are great options for cross-platform development. Their ability to run on different platforms makes it very easy to configure your project in a way such that switching from one platform to the other is seamless. So we've seen how it works on Mac. Now let's take a look at Linux so you can see that it works the same. It's easy. So I'm going to use the remote SSH extension to SSH into my Linux VM, and we'll build another CMake project there using the CMake Tools extension. It'll be a Fibonacci project. This project also has integration with vcpackage, and in this part of the demo, I'll show you the brand new, not released yet, vcpackage feature, which is support for a manifest file in your project directory. This will make it really easy to install project dependencies. All right, so let's get started. You can download the remote SSH extension from the extension marketplace. You can also download the remote extension pack, which includes the SSH extension, a containers extension, and a WSL extension. Today I'm using the remote SSH extension. To use the SSH extension, you'll click on the Remote Explorer icon on the left, and here you see a list of SSH targets that I've previously connected to from this computer. If you want to connect to a new SSH target, you can click on this plus sign and type SSH and then whatever it is you want to connect to. You can connect to an existing SSH target, which is what I'm going to do, by hovering over the target and clicking on this new window icon on the right. So this connects to the host in a new window of VS Code. Okay, so you can see it's opening the remote, and last time I was on this remote I had set the theme to be light theme. This will make it easy for us to tell which window I'm using. You can also look in this bottom left corner in the green rectangle where it says which SSH target you're developing on. All right, let's open a folder. So one important thing to call out is that the remote SSH extension in VS Code works differently than the remote SSH experience in Visual Studio. These source files, these projects, are actually on my Linux VM. Nothing is copied over from my host machine, from my Mac laptop. So this was a fresh VM. I SSH'd in, I cloned a couple of GitHub repositories, I installed GDB, GCC, etc. Everything is on that VM. So I'm going to open my project folder and open this example project. Okay. Cool. And here you can see IntelliSense is working properly on my Linux VM, and we have the integrated terminal. Okay, so let's configure and build this project using the CMake Tools extension. We'll follow the same steps as before. Here we can select a kit. So you'll notice this time all of the kits are GCC. These are the compilers that are found on my Linux VM. And then select a variant, select a bug. Let's configuring our project for us. Configuring done. All right, so now let's build and debug our project. We'll select build. Perfect. So we've successfully configured and built this CMake project using the CMake Tools extension on Linux, and we did it the same way we did it on Mac for SuperTux. Select a kit, a variant, configure, build. So I'm going to show you how I integrated this project with VC Package as well, and then I'll show you that new VC Package feature I was talking about, the manifest file in your project directory. So in this project settings JSON, once again, I set my CMake toolchain file path, and I'm going to set VC Package build on for the manifest file. And the manifest file is this VC Package JSON right here. So this lists the project dependencies. How VC Package works today is that you need to manually install your project dependencies, running VC Package install and then list all of the dependencies, which could be quite a lot. And if you're sharing project with coworkers or classmates, etc., sometimes you don't know what all the project dependencies are. So it's useful if you can just have a JSON file in that root folder, and then VC Package will pick up on that JSON file that lists all of those project dependencies. All you need to do is run VC Package from that project root folder, and it'll read the dependencies from the JSON file and install them for you. So let's look at how that works. So here I'm opening the terminal, and I'm going to go to my project folder. So you can see this is the folder with my source code, my build folder, etc. And from here, I'm going to run VC Package, install, binary caching. So you can see it's looking for CPP itTools and FMT, which are listed right here. And they're already installed, right? Which makes sense because the build was successful. So just to prove to you that this works, I'm going to remove FMT and let's run this again. There we go. And it built FMT using the cached binary package because I ran it with binary caching. So this is a really cool feature because then, as I said, all you need to do when you are opening a project on your computer is run VC Package install from that project root folder that has the VC Package JSON file, and it'll install all of the dependencies listed in that file for your project. You don't have to worry about manually doing each one. It's a lot simpler. I also want to mention that you can split this terminal by clicking on this split icon right here if you wanted to have more than one terminal open at once. And these terminals, you can see I'm actually in the project folders on my Linux VM, iterating once again. It's actually on the VM, it's not on my host machine. And if you want to switch back and forth between these two terminals, just do Command Alt arrow and the focus will change. So to debug this program, I'm setting a breakpoint at line 7 here. And if I hit debug, this will launch the debugger and it'll be using GDB under the hood. If we go to the debug console, you can see that it's using GDB, which I have on my Linux VM. All right, so if we step through the code, you can see how the local variables values are reflected here at the top of the pane. These are a couple of watch variables that I had created, and you can watch how their values change as I iterate through the code. If you wanted to create a new watch variable, you just click on this plus button. And let's disable the breakpoint, which I can do down here, and continue running through our program. There you have it, Fibonacci program. You can also customize your debug configurations in the CMake Tools extension in your settings.json file. there's a property called CMake debug config, where you can specify things like stop at entry to be true, which will have the debugger automatically set a breakpoint as you enter your main function. So now we've wrapped up the CMake Tools VC package remote development portion of today's demo, and I'm going to transition into talking about something different, which is how to optimize VS Code for collaborative development by integrating GitHub with Visual Studio Code. I'm sure a lot of you use GitHub when you're coding. I certainly do, whether you are sharing code with coworkers, contributing to an open source project, contributing to a shared project with a classmate. I use GitHub a lot, and I used to always use it in the terminal and then open the web browser, but you can really do everything right from VS Code, and it just makes your coding experience so much more productive because you don't need to leave the editor to merge and review PRs. You can do everything right there where you already are developing. So let me show you how this works. You can install the GitHub pull requests and issues extension from the extension marketplace. Once you install it, you can set it up to connect with your GitHub account by entering your GitHub login credentials. So I've already installed this extension and set it up to use my GitHub account. So let's make a change to a file and use VS Code to stage the changes, commit, and submit a pull request to my GitHub repository. So I have my own version of SuperTux forked on my repository on GitHub, and I have my own branch, will dev, which is what I'm using right now. You can see in this bottom left corner. So I'm going to push a change locally from branch will dev to my own fork of SuperTux. So I'm just going to edit this README file. Test2, save the changes, and if I want to see everything that I've changed in my local repository, so I know what I should be staging for a commit, I can click on this source control icon here on the left, and this shows me everything that I've changed, right? So here I have the README, and if I click on that from this source control panel, then I can actually see the changes that I've made to these files. So let's say I want to include this changed file in my pull request. I'm going to click this plus sign, and now it's added to my stage changes. Once you've added everything that you want to your stage changes, you can type a message. So edit readme test2 and commit the changes. And now to actually submit the pull request, we just click on this ellipses and select push. And you can see up here on this will dev branch, it's spinning, things are happening. All right, so I just submitted a pull request. Now let's go to the GitHub icon down here. In this GitHub panel, I see a list of pull requests. So you have local pull request branches, pull requests waiting for your review, pull requests that are assigned to you, created by you, etc. So looking at the pull request created by me, I can see here, so this is a pull request that I had already had open to merge a change from my will dev branch into my master branch, and I just submitted these changes to edit readme test2, so they got automatically added to this pull request. So if you want to actually see the changes in the pull request, you can go to this changes in pull request section in the GitHub panel and either start looking at the files, and it'll do a side-by-side comparison of what's different, or you can look at the changes on a commit basis and looking at the files included in each explicit commit. And so, yeah, you can just keep going through them. And if you have GitHub issues that are assigned to or created by you, they'll appear here in the issue section of the GitHub panel. Also, if issues are referenced in your code base, in comments maybe, the GitHub pull requests and issues extension will actually give you some quick cover information about those issues. So it's everything that you would want to do, everything you need to know about the GitHub repository that you're working with. It's right there in the editor for you. So let's just open this pull request again so you can see some of the functionality. You can add labels, such as bug, documentation duplicate, etc. You can add reviewers, you can add comments, you can approve or close the pull request. And let's say I want to merge this pull request, so I can just do that directly from here. Create merge commit. There, and this pull request status has changed to merge. Another really cool feature about Visual Studio Code for collaborative development is the Live Share extension pack. Live Share provides an untraditional way to pair program or develop collaboratively. And I say untraditional because all of the difficult things about collaborative development, like having to request control of someone's screen and only one person being able to control the navigating and editing at once, sharing your screen, or trying to clone a GitHub repo to reproduce the bug on your own device, and configuring your environment to match the environment of your coworker. You don't need to do any of that stuff. You can just use the text editor ID that you have set up on your computer exactly as it is, with no changes to your environment. So how it works is, if I open Visual Studio Code on my Mac laptop and I'm looking at SuperTux and I'm debugging and I want to start a collaborative session, the Live Share extension will generate a URL that I can then share with whoever I want. And then they can join the session through that URL in their instance of VS Code on their machine. So if I'm on my Mac laptop and someone else is on Windows or Linux, doesn't matter. They will join this session and see what I'm seeing, but then they'll also be able to navigate through my repository even on files that I'm not currently looking at. So you can co-edit independently. You can even do collaborative debugging sessions. It's really cool, so I'll show you how to use it. To start a live share session, you can open the live share panel on the left by clicking on this bottom icon. So now you see the options to join a collaboration session, start a collaboration session, start a read-only collaboration session. So I'm going to start a collaboration session. All right, and you can see in this notification on the bottom right that an invitation link has been copied to my clipboard. So at this point, I could share this with whoever I want. But for the sake of this demo, I'm going to use this link on my Linux VM. So I'm just going to SSH into my Linux VM and join the session on that VM. Normally, when you're doing this, it wouldn't be the same person joining the session from two different machines. However, for the purpose of this demo, that's how I'm going to be doing it today. All right, so let's connect to the SSH target. And a shortcut for doing that I didn't show you before is in this bottom left corner in this green rectangle. If you just click on that, it'll open a remote window. So we have remote SSH connect to host, and then you can see a list of saved SSH targets. Great. All right, and so I should have the link to this collaboration session copied onto my clipboard. And I'm going to click on this live share extension icon here from my remote Linux VM. And I'm going to select join collaboration session. Here, I'll paste the URL. We will just give it a reload. And there you see here, Visual Studio Live Share workspace, and it's loading my SuperTux project directory that's on my Mac laptop. All right, bear with me as I try to show both of these screens at once. So once again, this is my Mac laptop on the left and my Linux VM on the right using the SSH extension in Visual Studio Code. So I've joined the collaborative session from my Linux VM, and if I go look at the details of the session, you can see that there is a participant, that's me on the Linux VM. You can share servers, share terminals, and let me show you what it looks like to actually interact with the editor and see the other person's cursor moving around. So for example, you can see this orange cursor in my Mac window, which represents the blinking cursor on the right. And if I highlight something, you can see my name pops up. You can see what I'm highlighting. If I type something, you can see the updates in real time. And then if I go back to my Mac window, same thing, highlighting, you see my name, and you can watch me interacting. It's amazing. And if I move around, you can see the person who joined the collaborative session. They will move around with you until they start navigating on their own. So you can see it switched to this climbable.cpp file, but if I go on my Linux VM and now I want to go to a different file, once I've done that, we are navigating and editing independently. So the Live Share extension wraps up our last demo for today's session. So now I want to take a moment to do a quick recap of everything that we covered today. So first, we looked at some of the rich, productive C++ editing features provided by the C++ extension. This includes IntelliSense, find all references, rename, go to definition. Then I talked about some of the tools that we recommend for cross-platform development, since cross-platform development is very popular right now. The tools we recommend are CMake for building your project, itCppCon20 for managing your project dependencies, and Visual Studio Code for editing, since all of these can be used across Linux, Mac, and Windows. Within VS Code, we specifically used the CMake Tools extension and the Remote SSH extension to support our cross-platform needs. Lastly, I showed you how to optimize Visual Studio Code for collaborative development through the GitHub pull requests and issues extension and the Live Share extension pack. I hope you enjoyed the demos today. So that's how everything works today. Let's talk a little bit about what's coming next. So for itCppCon20, we have a couple of enhancements coming your way. The first is the manifest file, which I demoed for you today. The second is a first-class experience for managing private libraries with itCppCon20 so that customers can bring in their own libraries. Then customers will be able to use binaries to update rather than pulling from source every time so that it's faster. And itCppCon20 will support versioning, which means if your project has a dependency on an old version of a package, you can specify that specific version and use that in your project. For the C++ extension, we have remote development and debugging for Linux on ARM coming next. And as I said, these are all things that are in the works and we're planning to deliver, but we don't have specific dates set for when they'll be released. So if you're curious, the best way to stay tuned would be to check out the C++ team blog, which is at the link in this slide. We post feature releases, updates. It's a good way to stay tuned to what's going on. Lastly, please give us your feedback. The C++ extension, the CMake Tools extension, and itCppCon20 are all open source. The links to the GitHub repositories are on the slide. If you find a bug or have a feature ask, create an issue on the GitHub repository. We prioritize feature asks and bugs based on how many upvotes they have. So take a look at the issues that already exist, upvote the ones that you care about. And finally, please feel free to contribute to the repository yourself. We are always looking for contributors for all three of these repositories. Thanks so much for tuning into my session. I had a lot of fun putting this demo together for the Italian C++ conference. Please reach out if you have questions, concerns. The links to the GitHub repositories are in the slides. You can also find me on Twitter and LinkedIn. I look forward to watching the other talks and hopefully hearing from you.